Hi, so let's talk a little bit about forces and a little bit more. And we're going to talk about cars going around a curve at constant speed. Since they're at constant speed, but it's around a circle, we know that we have some centripetal acceleration. So we would have some centripetal acceleration in this direction. And then in the last section, you should have picked up that, since we have some acceleration in this direction, then we have to have a net force in that direction as well. So let me just mark that on there. So we know that we have a net force going in this direction for the car. But the question is, what's creating that force? And what we have to think about is just what's happening to the car, maybe looking at it from the above. So, if I had an object like this is my car and it's going around in a circle, the radius of the circle would be measured to probably about right here. But then the question is, what force is pushing it in this direction? And so what we can do is just take like a snapshot of the car at a moment in time, and our motion is in this direction. Remember that if it continued, it would just go in a straight line, but I don't have any sideways motion. And what's happening here is that the road is pushing back on the car. You kind of turn the wheel and the road pushes it. Let me see if I can draw like a little there. Those are wheels. Yeah. Don't make fun of my drawings. All right, so there's a car, and where it touches the road. So where it touches the road, when you start turning the wheel, what it does is it produces some friction going inward, and this frictional force is what is actually pushing the car, directing the car to make the curve. And so then we have, well, is it kinetic or is it static? Well, the car is not moving laterally, therefore this frictional force is going to be static friction. And it acts towards the center. That's what makes it curve. So let's see how this all plays out, because we can use this to do some calculations. So first, let's start with a force diagram. So here's the car. And of course, we have some weight. And because we have weight, we have an opposing normal force. And since we're going to assume that this is a level, although this is actually going downhill, and then what we have is we have this force acting toward the center. And when we label it, we're going to call that the centripetal force. So write that here to the side. Fc is the centripetal force, not to be confused with centrifugal, which is not a force. The centripetal force. So the force acting towards the center of the circle. And we know that this centripetal force is due to static friction, which would be the coefficient of static friction times the normal. That's our definition. So centripetal force for this case is going to be due to static friction. So let's say we were given some quantities. Let's say we were given like the mass of the car. So let's say the mass was 900 kilograms. The velocity the car is moving at is 18 meters per second. And the radius of the curve that's measured from where the car is to the center of the turn is going to be 50 meters. Well, then we can answer some questions. We could answer, what is the centripetal force acting on the car? What's the total force that's pushing the car around the curve? We could also ask, what's the coefficient of friction, the static coefficient of friction, between the tires on this car and the road that it's driving on. Remember that it can change, but just say in this instance. And so now we can just do some calculations. So we'll start with the centripetal force is going to be equal to the mass times the centripetal acceleration. So you see it's just Newton's second, except we're talking about centripetal force and centripetal acceleration. And then we learned earlier that the centripetal acceleration is going to be the velocity squared divided by the radius. So we get the centripetal force is equal to mv squared over r. Substituting, centripetal force is going to be the mass, 900, times the velocity, 18, squared, divided by the radius, which is 50. And we do that calculation, we get 5832 newtons. So that's the entire centripetal force. But then we had another question. The other question was, well, what's the coefficient of static friction? Well, I know that my centripetal force is equal to my static friction, which is the coefficient times the normal. So I know that my coefficient, if I divide here, I know that my coefficient of static friction is going to be the centripetal force divided by the normal. Further, we know that the normal force is going to be equal in magnitude to the weight because this is a level surface. So we know that that's just going to be mg. So we get the coefficient of static friction is the centripetal force, which was the 5832, divided by the mass, 900, times 9.8. So our coefficient of static friction is going to be 0.66. And that's about right. A standard tire on a standard road is about 0.7 on a dry road. On a wet road, it drops to about 0.3 or 0.4. That's why you'll slip around a curve. You need to slow down. And that's it. So you're going to answer a few questions, and then you'll get your XP.